We're going to introduce systems of equations now, which is one big area where we can use linear functions to answer questions. The definition is pretty straightforward. A system of equations is a group of two or more equations. So if I have the equation x plus y equals 7, that by itself does not constitute a system. But if we pair it with another equation, x minus y equals 1, now we have a system. In practice, the equations in a system usually represent separate pieces of information. For instance, x plus y equals 7 is another way of saying that the sum of two numbers is 7. On the other hand, x minus y equals 1 is another way of saying that the difference of two numbers is 1. So these are two separate pieces of information that we're going to try to reconcile through the system. Usually when we have a system, we are most concerned with finding a solution. A solution is a pair of numbers that satisfy all of the equations in the system. So let's take another look at the system we had from the last slide. X plus y equals 7, x minus y equals 1. A solution is supposed to be a pair of numbers written as an ordered pair. And let's test out, say, 5, 2. If 5, 2 is going to be a solution to our system, then it has to satisfy all of the equations in the system, meaning it has to satisfy the first equation and it has to satisfy the second equation. So let's check and see if it's a solution. What we're going to do is plug in 5 for x and 2 for y in each equation and see if we end up with something true. So for the first one, we would have 5 plus 2 equals 7. Well, that works. That's good news. And now we check the second one. 5 minus 2 equals 1. Well, if we subtract 5 minus 2, we get 3. And 3, unfortunately, is not equal to 1. So our point 5, 2 satisfies the first equation, but it doesn't satisfy the second equation, and so it is not a solution to the system. In this example, we are given a point for -2, and we are asked to determine if it's a solution to the system. To check and see, we can plug the values x equals 4 and y equals -2 into each equation and see if we end up with true statements. So for the first one, we would have 3 times 4 minus 2 times -2 equals 16. Well, let's see. 3 times 4 is 12, and then -2 times -2 is plus 4. That works. Now we go to the second equation. 4 plus 5 times -2 equals 11. Let's see. 5 times -2 is minus 10. 4 minus 10 equals 11. Unfortunately, that's not true. And so we can say that 4 -2 is not a solution. Let's try another point and see if we can find one that works. How about 6, 1? Let's test that one the same way we tested for -2. So we'll take 6 and plug it in for x, and 1 and plug it in for y. 3 times 6 minus 2 times 1 equals 16. Well, 3 times 6 is 18, and 2 times 1 is 2. 18 minus 2 is 16. That checks out. Now let's check the other equation. 6 plus 5 times 1 equals 11. 5 times 1 is 5. 6 plus 5 equals 11. That checks out as well. Now we found a point that is a solution. 6, 1 is a solution to our system. Now let's look at the graphical side of systems. Here we have the system we were working with earlier, x plus y equals 7, x minus y equals 1. Each of these is a linear function, and so we can graph them just like we've graphed lines in the past. We'll need to get each one into slope-intercept form to do that. For the first one, we have x plus y equals 7, and we can subtract x from both sides to see that y is equal to negative x plus 7. For the second equation, we have x minus y equals 1. So once again, we can subtract x from both sides, and we end up with negative y equals negative x plus 1. And now we can get rid of the negative by multiplying both sides by negative 1. And we end up with y equals x minus 1. Let's graph both of these and see what they tell us about the system. Here's the picture of our lines. Now let's think about the solution. A solution is supposed to be a point that satisfies both the first equation and the second equation. Well, to satisfy the first equation, x plus y equals 7, means that the point has to be on the blue line. So we're looking for a point on the blue line. On the other hand, to satisfy the second equation means that the point has to be on the red line. So we are also looking for a point on the red line. Well, there's only one point that's on both the blue line and the red line. It's the point of intersection. So the solution must be the point of intersection of the two lines. And the coordinates of that point are 4, 3. And that's going to be the solution to our system.